So here we have a normal distribution, and a standard normal means we're working with z-scores. So the mean is 0, and then a standard deviation is exactly 1 unit. So 1, 2, 3 standard deviations to the right is a z-score of 3. -1 for z is a standard deviation of 1 to the left. From the empirical rule, I know things like there are 68% of the data within 1 standard deviation of the mean. So if I mark off 1, it's not very symmetric, but make believe it is, 1 standard deviation on each side, then in this region in the middle here, I should have 68% of the data. If there's 68% of the data in the middle, then that leaves, what, 32% to split on each side. And since this is symmetric, that means 16% of the data must live out in this wing right here. So if somebody asks me, hey, what's the probability that somebody has a z-score in a normal distribution that is less than -1, then I would say, oh, well, that would be 16% of the data according to this part of the empirical rule. So that would be about 0.16. Another way to think about it also is that means a z-score of -1 leads to the 16th percentile, because 16% of the data is at or below that point. So for z-scores, p16 is -1. Okay? It is the value that puts 16% of the data at or below that point. And so a less than probability is the same thing as a percentile. In this case, we were given a z-score of 0.13, and so that lives maybe right over here-ish, z of 0.13. And so we want to know what's the probability, if we draw a line here, of anyone having a z-score under that, so in this range over here. Well, the mean marks the median also, so 50% of the data is below 0, so it should be just a little greater than 50. How much greater than 50? Well, we got to do a little work to calculate that. Recommendation in this problem is to use StatKey or the NormDist calculator in a spreadsheet. And I'm going to use StatKey, it's a little bit easier. So standard normal, mean 0, standard deviation 1. So we click the link here, that takes us over to StatKey. And in StatKey, they start off with a mean of 0 and a standard deviation of 1. If you want others, you can edit those parameters. I'm doing a left tail because it's a less than, which is also a percentile, and I want the z-score to be 0.13, 1300ths. And so this says that means this would be about the 55th percentile, because 55.2% of the data lies below a z-score of 0.13. So the answer to this problem would be 55.2% as a percentage, or 0.552 as a decimal. And let's see, was we given any advice on that? Just said calculate as a probability, so then we would enter up here 0.552 would be the calculation we found for this region of the graph here. Okay. So I kind of did a rough guess by thinking about the empirical rule, and also just a reminder of how z-scores and percents relate on a normal distribution. I hope that was helpful. See you later.